Okay, here's a good shockwave sonic boom problem. So we got a jet plane flying overhead at Mach 1.7 at a constant altitude, and we're going to find some stuff out about the shockwave. So pause and read. Hopefully you've done that. So ignore my terrible drawing here, but remember a shockwave doesn't occur directly over your head. So here's our plane flying. When the plane was way back here, it's been making a shockwave for who knows how long. It doesn't matter. But when the plane gets here, the sound from the plane is going to travel directly toward our guy or you, whatever, standing right here. The sound's going to travel down here while the plane travels here. The plane is traveling faster than the speed of sound in air. So this distance here will be shorter than this distance here. Well, if we look at this angle right here, we call this angle alpha, then in this big right triangle here, sine of alpha would be the distance the sound traveled to get to you over the distance the plane traveled to get from here to here. This is where the plane is when you hear the shock wave. This is where it is when it made the sound you heard. This is where it is when you see it. So the sound was traveling to you while the plane was traveling here. You hear it when it's here. It made the sound when it was here. Okay, so sine of alpha here would be Vt over Vst. The t's would cancel and we get sine of alpha is V over Vs. V is the speed of sound in air. Vs is the speed of the source. We're told our Mach number is just the reciprocal of that. That's how many times faster than the speed of sound you're going. So this plane is going 1.7 times the speed of sound. That's the definition of Mach number. It's just the reciprocal of this fraction. So flip that over and solve for alpha. We get alpha is 36 degrees. Okay, so that's this angle here. Now we're going to figure out how much time it takes, not for this whole trip. This question's weird. The question says, okay, now measure from here, from the time it flies over your head until you hear it. How much time did that take? So we're going to look at this right triangle here. We know this angle, we just solved for it. It was, 36 degrees? So tangent of this angle, tangent of 36, will be the altitude, which they told us, over this distance right here. Not the total distance, not what I have written there, just this distance. Well, that distance there will be the speed of the plane times the time it takes. So tangent of alpha will be altitude over this distance. And that's what we're trying to solve for, is time right there. So now we just do some algebra and we solve for the time, about 3 seconds.